All right, this video is for Learning Target 10. It's part 2. In part 1, the video, we were evaluating a summation notation or sigma notation, kind of expanding the sigma out to finding the terms that the sigma was referencing and then adding them up. Well, now we're going to work backwards, and in working backwards, we're going to see almost every learning target of the unit so far. Learning Target 2, 4, 5, 7, 8, 9, 10, and even Learning Target 1. So everything but the geometric and arithmetic means are going to be involved in this video. So 3 examples. Number 1, arithmetic. So our first problem, we're dealing with arithmetic. So we've got 2 formulas that I'll just remind you. A sub n equals a sub 1 plus n minus 1 times d, and s sub n equals n over 2 times a1 plus an. Our goal is to write it in summation notation, aka sigma notation. So we'll start with the blank sigma and kind of 3 boxes that we need to fill in. First, if given the choice, always start with n equals 1. So we're declaring that the 7 is the first term. So n equals 1 is our starting term. The next thing, we're going to find the rule that goes in this box. That rule is the explicit rule for this arithmetic series, which can be found using Learning Target 4. A sub n is first term 7 plus n minus 1 times the d, which we can figure out is 4. We'll distribute the 4, combine like terms, and 4n plus 3 is your explicit rule. So that's what goes there, the explicit rule for this series. The last thing I need to know is what number to put at the top of the sigma. It goes with the 207. So what is the n? What term is 207? Is it the 50th, the 20th? I don't know. But we just wrote an explicit rule, 4n plus 3 for all the terms. So we can take 207 and set it equal to the 4n plus 3 and solve for the n. Subtract 3. So 204 equals 4n, divide by 4, and 51 equals n, which means 207 is the 51st term. So 51 goes there. And we have checked. Step 1, wrote that series in sigma notation. The last part says evaluate each sum. So in evaluating this sum, I'm going to use the old sum formula. The sum of these 51 terms is equal to 51 divided by 2 times first term 7 plus last term 207. And that's your Learning Target 8. And the answer, which I'm not typing this in the calculator because I've got the answers over here, is 5,457. So 5,457 if you type that in the calculator. And we just did Learning Target 2 when we found the 51 for n. We did Learning Target 4 when we wrote the formula for the explicit rule. And we used Learning Target 8 when we used the sum formula at the very end. So that was all arithmetic. Now we switch gears to geometric. So those formulas are a sub n equals a sub 1 times r to the n minus 1, and s sub n equals a sub 1 minus a sub 1 times r to the n over 1 minus r. For starters, in sigma notation, we got those 3 boxes to figure out. We're going to decide or declare that the first term is 3, so we're going to start with n equals 1. That makes 6 the second term, 12 the third, 24 is the fourth. I don't know what term that 6144, that 6,144 is. That's probably going to be an issue later. In fact, we know that's going to be an issue because that number n goes in the top. But let's deal with the explicit rule first. Since it's geometric, we're using this formula for the sequence. First term 3, and the r is 2. So 3 times 2 to the n minus 1, and that does not reduce. You can't multiply 3 times 2. That's Learning Target 7. So go back to that video if you have a question there, but it's 3 times 2 to the n minus 1. And then in finding the n for that term, 6,144, we're going to use that explicit rule that we just wrote and put 6144 into the term spot and figure out what the n is that goes with it. So step 1, divide by 3. So we'll pull the calculator up for this. Let's see. 6144 divided by 3, whoops, divided by 3, 2048 equals 2 to the n minus 1. And then it's a guessing game. 2 to the what power makes 2048? Well, let's see. We're going to guess 2 to the 9th. Too small. 2 to the 11th. There it is. 2 to the 11th. So think about that. If n minus 1 becomes 11, what did the n have to be? It had to be 12. It had to be 12 minus 1 to make 11, which means we now know that the 6,144 is the 12th term. So we put a 12 on top of the sigma, and we have finished writing that series in sigma or summation notation. Last step, find the sum of that series. I'm going to pull the old sum formula out. Sum of these 12 terms is first term 3 minus first term 3 times R2 to the nth power 12 over 1 minus R, and that's learning target 9 if you need to go back excuse me, if you need to go back to that video. But we have the answers over here, so that becomes 12,285. 12,285. Last problem. The last problem is neither geometric nor arithmetic. So this is going to bring back learning target 1 when we go to write the explicit rule for the pattern. But we start again by our 3 boxes. Again, we're going to declare n equals 1. We're going to start with the first term. The 1 is the first term, the 4 is the second term. 3, 4, 5, blah, 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 to n equals, don't know. So if we're starting with n equals 1, then we need to figure out the formula. I picked a pretty easy formula to figure out what is it that you do to n the 5 to make 25. Well, you take that 5 and multiply it by 5. What is it that you do to 4 to make 16? You do 4 times 4. In other words, you take the n value and multiply it by itself. So the a sub n formula is n times itself, n squared. So n squared goes there. Then it doesn't take long to figure out, well, what would you square to make 225? Now we put 225 in here, and n squared. We could take the square root of both sides. N is 15. So the 225, the last term, is the 15th term. Unfortunately, there's no formula to do this for us, so the only real way to finish this problem is to just add up all the perfect squares up to 15. So we've got the list of 25. So what would be next would be 6 squared, 36, then 49, then 64, then blah, 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 all the way to 225. And I've got those over here on the other screen. So there's a list of all of those numbers. And I actually didn't add them up. So I guess we need to do that for the video's sake. So this will take a little while. 1 plus 4 plus 9 plus 9 plus 16 plus 25 plus 49. That's all right. I'll go back and get 36 plus 64 plus 81 plus 100 plus 121 plus 144 plus 169 plus 196 and one more plus 225. Oops. Glad I caught that. Plus 225. Enter. 1240. 1,240. 1,240. All right, and that's the end of the Learning Target 10 note.